Fabian Sabugal, creator and developer of Reaper Eagle Technologies. Today, I'm gonna walk you through my Onco Triage software for detecting lung anomalies and nodules in your lungs. So, let's start. As you can see, you get a pretty nice interface. So, let me walk you through it. You get this nice interface the that features metrics of performance, but these metrics are for the engine. We're talking about the AMD specialized IM 300X engine. So here's the main panel that shows analyzed cases, patients that might be at risk, which are lying. There's the accuracy of the model based on metrics extracted from a benchmark and then compared against other state-of-the-art software and some other like models combined, like if ResNet, Monte Carlo Dropout, some other models. There's also an important part of this software, which is latency. Latency is important, especially in the medical field, because what's the point of having a state-of-the-art engine if the latency is going to be high? That the engine is going to take like minutes to process an X-ray. So what's the point of that? So here's the latency from the efficiency marks and metrics of the model. There's also like the thermic load of the engine to show like how saturated or how stressed the engine has been. If the engine has been basically put under stress with, I don't know, X-rays. So this, the engine can process a large batch of images as opposed to its predecessor, which underpins this software, which is CDSS pneumonia, which is a software I developed for detecting pneumonia um, in X-rays. But that model is the black box. And I will go into further detail with my software here because it's self-explanatory. So what I mean by this software not being a black box is that here we go. A when you process an X-ray, you can have normal cases. So the software is not gonna flag a benign case, so it's gonna be okay. But when there's a zone of interest, the software is gonna flag it and it's gonna show it in the heat map. And this is why the software is in a black box, because it shows where the model has extracted its diagnosis. And not only that, but also the uncertainty. We're not talking about, okay, here we go. You, you probably. So my software is not like, hey, you might have a cancer. There's a strong likelihood that you might have cancer. No, my software says no, not on my soul. Here's the confidence, the quantified risk, and the detected regions. So my software is not a black box. So the detected regions work through a heat map. So there's the toggle. If you turn the toggle on, it will show you where you might have a high likelihood of a nodule or an anomaly in your lung. So here, for example, it says that you should get checked you with a specialist. Now, when that's a benign case, there comes the green pop up with zero regions of interest. So uh, the quantified risk is way lower than when it detects an anomaly. For example, here there's there's an anomaly in your lungs, and there's two regions of interest. And so when you toggle on the heat map, it will show you. So, for example, EfficientNet before, unlike ResNet 50, is way more accurate and detects smaller anomalies in your lungs. And when the anomalies are way more prominent, the heat map will be way bigger. And for example, here says that you should get checked a biopsy diagnosis with a professional. And that's why I'm highlighting it. And there are three regions of interest here, so that facilitates and makes it easier for an oncologist and radiologist to like diagnose you with I don't know, you there's a likelihood that you might have cancer, so you should get checked and under control. For example, here is riskier because there's a morphologic region with an anomaly, and there are three regions. So even if you zoom in, it is hard for the naked eye to detect these anomalies because efficient as before, it works like enlarging the image, creating a higher resolution image, so it can detect millimetric anomalies. So, for example, here this set of lungs looks normal. If you toggle the heat map off, I mean, it looks way normal. There are some dots on the lungs, but uh, the anomalies are millimetric, and that's why cancer is so dangerous, because it might go unnoticed. So what otherwise might be a healthy set of lungs, here it detects it millimetrically. So, for example, there are three regions here. So, to the naked eye, you might say, "Well, that's normal. That's your body. How can it be abnormal?" But also, the software has this option to export a PDF report of the anomalies found in the batch of x-rays that you processed. For example, here I processed the report without the heat map, but if you toggle the heat map on, the report will have these heat maps printed on every page. So here, for example, there's the uncertainty and all the other metrics that were used to diagnose the x-rays and for example, the labels: benign case, normal case, malignant case, and a summary of the batch you processed. Now, moving on to another important part is the triage. The triage part is important because patients have to be categorized and they must fall into certain categories. Unlike the predecessor of this software, here the triage is way more strict. And why? Because cancer can go unnoticed. You gotta detect it ASAP, as soon as possible, so it cannot go undetected. And that's a certainty. If you let it grow, well, you will have big problems. So this would be like the functionality and an overview of my software, which will use the AMD GPU instance. So I thank everybody who stuck around and listened to me talking about my software. So I hope you liked it, and let's hope to do way bigger things than this.